Chapter 12.6, Surface Area and Volume of Spheres. A sphere is the set of all points in space equidistant from a given point. This point is called the center of the sphere. A radius of a sphere is a segment from the center to a point on the sphere. A chord of a sphere is a segment whose endpoints are on the sphere. A diameter of a sphere is a chord that contains the center. So just like a circle, the sphere has a center. And if you extend the segment from the center to the sphere itself, that's a radius, just like the circle. And again, like the circle, if you go a segment from one end of the sphere, one part of the sphere to another, that's a chord. And a chord that goes through the center, right through the center, that's a diameter, just like the circle. Okay, so the surface area, S of a sphere, is 4 pi r squared. So this is the formula for the surface area of a sphere, 4 pi r squared, where r is the radius. All right, so pretty simple diagram. We have the sphere and we have its radius r. Surface area is 4 pi r squared. So one way to derive that formula is to look at the leather covering on a baseball. Okay, if you check out this leather covering here, it basically consists of 4 circles, and we know that the area of a circle is just pi r squared. All right, so we have 1, 2, 3, 4 circles on the leather covering that wraps around a baseball. A baseball is basically a sphere. Example 1, find the surface area of the sphere. All right, very simple. We have our sphere. This is clearly the center, and the segment that goes from the center to the sphere itself is a radius. So this is the radius r, and r equals 8 inches. All right, so we said the surface area for the sphere is 4 pi r squared. So you just plug in 8 in place of r. So that's going to be 4 times pi times 8 squared. Let me see if their answer is rounded off. Okay, they actually did both. So if I were to leave this in terms of pi, I would just do 4 times 8 squared. Okay, 4 times 8 squared is just 256. So that is 256 times pi. And the units on the radius were inches, but the radius got squared, so that's going to be inches squared. All right, and if I wanted to round off, I multiply this through 256 times pi on the calculator. I get 804. And if I did 2 decimals like they did, it's going to be 0.25. Okay, the decimals kept going, but I just rounded off to 2. So this would be the exact answer in terms of pi, and this would be the rounded off answer to the nearest hundredth. Example 2, the surface area of the sphere is 20.25 pi square centimeters. What is the diameter of the sphere? Okay, I think they have a diagram, but really we don't even need it. The take-home thing here is to know that the surface area is 20.25 pi, and they want the diameter. Okay, the diagram doesn't do much anyway, so we have to work backwards here. Once again, the surface area for a sphere, that is 4 pi r squared. Okay, so the surface area is given in place of S, 20.25 pi. And that equals 4 pi r squared. Okay, these numbers are all multiplied, so r squared is basically multiplied by 4 times pi. So the way to solve for r squared and get rid of 4 pi, the opposite of times 4 pi, is divided by 4 pi. We're going to do that to both sides. All right, on the right, 4 pi over 4 pi cancels. Pi divided by pi cancels. And you can get a number for this, or you can just take the square root of this as is. I'll get a number just so I don't confuse people. Okay, 20.25 divided by 4. That's going to be 5.0625. 5.0625. And that equals r squared. Solving for r, the opposite of squaring something is to take the square root. So I do that to both sides. And the square root is 2.25. So square root of r squared is just r. And they asked us for the diameter. This right here would be the radius, but the diameter goes all the way through. So the diameter is basically 2 times the radius. All right, so the diameter is going to be 2 times 2.25, which of course is just 4.5. Okay, or you can say 4.50, same thing. Anyhow, the units originally were centimeters squared, but when we took the square root, the squared part gets removed, and it's just centimeters. Okay, and like I said, you can get a number here if you want, but you could have just taken the square root of this fraction right here in one step, if you wanted to do all calculator work in one step. So it was multiple choice, and that would be answer B, 4.5 centimeters. Okay, please try guided practice number 1. It says the diameter of the sphere is 40 feet and find the surface area. You can do it in terms of pi, or you can round off to 2 decimals. All right, so pretty easy. We said the surface area for the sphere is 4 pi r squared. All right, so they gave us the diameter is 40 feet, and we know the radius is half of that. So half of 40 is just 20. So for r, radius, we're going to be using 20. So this is 4 times pi. In place of r, we're going to plug in 20. So that's 20 squared. Okay, in terms of pi, 4 times 20 squared gives us 1,600. So if you want it in terms of pi, that's 1,600 pi. The units were in feet, but feet got squared, so that's going to be feet squared. Remember, for an area, the units get squared. All right, and if you wanted to round off, I'll do 1,600 times pi on the calculator, and if you round off, 5,026. Okay, I get 5,026, and if I did 2 decimals, it would be 0.55. So again, the units are just feet squared. So this is exact, and this is rounded off. Okay, please pause and try number 2. In this case, they give you the surface area is 30 pi in square meters, and they want you to find the radius. Please try it. All right, same formula, but we're working backwards. The surface area, S, is 30 pi, so in place of S, I'm just going to plug in 30 pi. And that equals 4 pi r squared. All right, these terms are all multiplied by each other. The r squared is times 4 pi. So the opposite of times 4 pi is divided by 4 pi. You want to do that to both sides. On the right, 4 pi over 4 pi cancels. On the left, pi over pi cancels. And this is going to be 15 over 2, which is just 7.5. And that equals r squared. Okay, the opposite of squaring something is to take the square root. So I do that to both sides. And the square root of 7.5 is a long decimal. It's 2.7386. Okay, I think 2 decimal places is enough. So you look at the third one. If it's more than is 5 or more, you round this up. So I'm going to say R is approximately 2.74. All right, the units were in square meters, but when we took the square root, square meters is meters squared. When we took the square root, we removed the squared. So the final units on the radius are just in meters. All right, so I made my own example for this one. I wrote, if the circumference of a sphere is 12 pi feet, what is its surface area? Okay, we know that circumference is the distance around a circle or a sphere. And the formula for circumference is 2 times pi times r. Now, we need r for the surface area. So we have to work backwards here. It's given the circumference is 12 pi, so in place of c, I'm going to plug in 12 pi. And that equals 2 pi r. Okay, again, like we said before, these numbers are all multiplied, so this is basically r times 2 pi. The opposite of times 2 pi is divided by 2 pi, so you want to do that to both sides. 2 pi over 2 pi cancels. Pi over pi cancels, and 12 divided by 2 is just 6. So the radius is 6. All right, that's in feet, but we'll leave it as is for now. All right, and now let's move on to the surface area. Since we have r equals 6, we can easily find that. The surface area is 4 pi r squared. So that's going to equal 4 times pi, and r squared is going to be 6 squared. All right, in terms of pi, I'll do 4 times 6 squared. And I get 144 times pi. Okay, the units were in feet. These units were also in feet. But right here, the radius was squared, so that's going to be feet squared. And if I multiply it through and round off 144 times pi, I get 452.39. And that's also in feet squared. So this is the exact answer, and this is the rounded answer. All right, please try guided practice number 3. It says in example 3, the circumference of the inner ball is 6 pi feet. Find the surface area of the inner ball. Round your answer to 2 decimal places. Okay, so in example 3, they had an inner ball and an outer ball, but that's not really relevant. All we need to know is that the circumference is 6 pi feet. So that's going to be your C, 6 pi feet, and they want you to find the surface area. So please do that just like we did it in the previous example. All right, we said circumference is 2 pi r. And they gave us the circumference is 6 pi, so that gets subbed in place of c. And that equals 2 pi r. Okay, this is r times 2 pi. The opposite of times 2 pi is divided by 2 pi. So we do that on both sides. 2 pi over 2 pi cancels. Pi over pi cancels, and 6 divided by 2 is just 3. So that's your radius. And then for surface area, 4 pi r squared. So we have 4 times pi times r squared, which is going to be 3 squared. All right. 3 times 3 is 9. Times 4 is 36. So that's going to be 36 pi. The original units were in feet, but for surface area, they get squared, so that's feet squared. And they said they round off actually to 2 decimal places. So if I did 36 pi, I get 113.10. And that's in feet squared. Final answer. Now for the volume of a sphere, we're looking at 4/3 pi r cubed. Okay, so r is raised to the 3rd power in the volume of the sphere. R is the radius. So this is the formula for the volume of a sphere, 4/3 pi r cubed. Example 4, the soccer ball has a diameter of 9 inches. Find its volume. All right, they didn't really give us a diagram, just a picture of the ball. The diameter is 9 inches, so that would basically go from one end of the sphere to the other, and it would have to go through the center. Anyhow, we said the formula for volume is 4/3 pi r cubed. Okay, just for your information, the 4 and the pi and the r cubed are all in the numerator, and the 3 is in the denominator. Okay, so if it helps you, you can write it like this: 4 pi r cubed divided by 3. All right, that's the same thing. Anyhow, if the diameter is 9, we know the radius is half of that. So the radius is just half of 9, which is 4.5. And that's in inches, of course. So we need the 4.5 in place of r. All right, so we have 4 times pi, and in place of r, 4.5, and that's raised to the 3rd power. And that whole thing is divided by 3. So in their answer, they did both. I'm going to do both. All right, if I leave pi alone, I'll do 4 times 4.5 to the 3rd, and then divide by 3 at the end. Make sure the exponent is only on the 4.5 and not the 4. Okay, so I'm going to do 4 times 4.5 to the power of 3, hit equals, and then divide by 3 at the end. Hit equals, and I get 121.5. All right, I left pi alone, so I still have pi. And now, the original units were inches, but when we plugged in, inches were raised to the 3rd power. Okay, so that's going to be inches to the 3rd power. And that's pretty much always the case with volume, that it's raised to the 3rd power. If I multiply through 121.5 times pi and round off, I get 381.70. Okay, so the estimate is 381.70. And that is inches cubed. All right, challenging problem here. Example 5, find the volume of the composite solid. So here's our composite solid. It's a cylinder, and it actually has a dent in it right here. See this half a sphere right here? This in here is actually a space. It's empty space. So the top of this cylinder, it's called a hemisphere. And a hemisphere is basically half of a sphere. Okay? And that right there is actually empty space. I don't know if I can draw it any better than they did, but like, try to imagine if this portion of this is a cylinder, and imagine if this portion were missing, like the top half or the hemisphere. Imagine that was missing, and we wanted to find the area of just this part. We would have to find the area of the whole cylinder and then subtract this hemisphere or half sphere. All right, let's see if we can pull it off here. So the total volume, we're looking to find the volume. That's going to be the volume of the cylinder minus the volume of the sphere. However, it's not a whole sphere. Okay, this part right here, see, it's cut off. This is flat right here. So imagine a sphere that's cut off. It's half of a sphere. So we're only subtracting 1/2 of a sphere. Okay, and now if you recall the volume of a cylinder, that is base times height. I'll write it separately. If you recall the volume of a cylinder, all right, I'm doing this separately here. Volume of a cylinder is capital times height. But the base of a cylinder is a circle, and the area of a circle is pi r squared. So this is the formula for the cylinder, pi r squared h. All right, so in place of the volume of the cylinder, pi r squared h. And that's minus 1/2. And we said the volume of the sphere is 4/3 pi r squared. I meant to say r cubed. All right, and since we have fractions here, we might as well cancel. This is 1/2 times 4/3. 4 divided by 2 is just 2. All right, so if you want to rewrite this, if it helps you, we have pi r squared h minus, and 1 times 2 is just 2, and 2 is times pi times r to the third. So that's times pi times r to the third, and the only denominator left over on the bottom is the 3, so the whole thing is divided by 3. All right, so we need r and we need h. If you go to the diagram, go from the center to the circle, that's your radius r, and that's 2 inches. And also right here on the side of the cylinder, the height h also happens to be 2 inches. So 2 inches for both h and r. Okay, I have pi. In place of r squared, that's going to be 2 squared. And in place of h, that's also going to be 2. Minus 2 times pi. R to the third is going to be 2 to the third. And that whole thing is divided by 3. All right. Now, if you wanted to keep it in terms of pi, it's a little bit tricky. I'll just show it to you just so you know. 2 times 2 is 4, times 2 is 8, so this is 8 pi. Minus 2 to the third is 8, times 2 is 16, so in the numerator it's 16 pi, then divided by 3. Okay, now you need a common denominator. So we need this to be over 3. 8 times 3 is 24, and we still have pi, and now that's divided by 3, and that's minus 16 pi over 3. Okay, so 24 minus 16 is 8. We still have pi, and we still have a 3 in the denominator. The units were in inches, but for volume, inches gets cubed. So that's going to be inches cubed. All right, this is a little bit tricky, but if you wanted an exact answer, that's what it would be. If you wanted to round off, you can just do this whole mess on the calculator, okay? Yeah, you could type this as is in the calculator, and you should get the correct answer. All right, but anyhow, 8 times pi divided by 3. Okay, if I did 8 times pi divided by 3, I just get 8.38 if I round it off. And that is in inches cubed. Okay, please pause and try number 4. The radius of a sphere is 5 yards. Find the volume and round to 2 decimal places. All right, so this one's pretty easy. I want you to use 4/3 pi r cubed and round to 2 decimal places. Please try it. All right, it said the radius is 5 yards. Okay, so r is going to equal 5. All right, so in the formula here, we have 4/3 times pi times r cubed, so that's going to be 5 to the 3rd power. All right, so they said we can round off, so I'm going to do 4 times pi times 5 to the 3rd. Okay, 4 times pi times 5 to the 3rd, hit equals, and then divide by 3 at the end. And rounding off, I get 523.60. The units were in yards, but the yards got cubed. So that's going to be yards to the 3rd power. All right, last one. It says a solid consists of a hemisphere of radius 1 meter on top of a cone with the same radius and the height of 5 meters. Find the volume of the solid and round to 2 decimal places. All right, I'm going to draw this for you, but it's basically an ice cream cone. Okay, so if I were to draw this, let me make a little more room here. If I were to draw this, I would just do an ice cream cone, okay? They said the bottom part is a cone, and the top part is a hemisphere, so it's going to be half of a sphere. Okay, so it's basically something like this. And hard for me to draw, but they said the radius is 1 meter. Okay, so the radius is just 1 meter. I'll draw that in a different color. All right, the radius would basically start here and go to the hemisphere. So that's 1 meter. And it said the height is 5 meters. So the height right here is 5 meters. All right, now the bottom is a cone, and the top is a hemisphere, or half of a sphere. So the volume, do that in a different color. The volume is going to be the volume of the cone plus 1/2 the volume of a sphere, because this is a hemisphere. Okay, and unlike the last problem, there's no space here. This is added onto the top. So that's going to equal the volume of the cone, which we said was pi r squared h. And then 1/2 the volume of the sphere. So the volume of the sphere is 4/3 pi r cubed. Okay, just like last time, the 4 divided by 2 cancels, and that's just 2. And you're left with 2 pi r cubed over 3. Okay, so this right here is the radius r, that's 1. This right here is the height, that's 5. See if you can solve it and round off to 2 decimals. All right, so let's see, mostly calculator work. We have pi r squared, so that's going to be pi times 1 squared times the height, which is 5. And here in the numerator, we have 1 times 2 times pi times r cubed. 1 times 2 is just 2, times pi times r cubed, so that's going to be 1 to the 3rd power. And that whole thing is divided by 3. All right, so I'm going to let the calculator do all the work this time. I'm not going to do it in terms of pi. Okay, I'm just going to type pi times 1 squared times 5, and I'm going to hit equals, and then I'm going to do plus 2 times pi times 1 to the 3rd, or just 1, divided by 3. Hit equals again, and I get 17.08. The units were in meters, but this is a volume, so it's going to be meters to the 3rd power. Now, if you had bigger numbers here, what I would do, let's say that 1 was something different, you might not have an easy time. So what I would do 2 times pi times 1 to the 3rd, or whatever the number was. 2 times pi times 1 to the 3rd, hit equals, then divide by 3, hit equals again, and then I would add this part here. I would do plus pi times 1 squared times 5, and hit equals the final time. I still get the same answer. All right, so just be careful with your calculator work. You might have to do 2 separate steps.